How's it going, everyone? Welcome. Oliver Gonzalez here, exploring at the RxGS, which is part of this. Well, this is a course of rethinking synchronicity in JavaScript, but the reality is that I'm here to explore is what means asynchronicity in JavaScript, which is at the end of the day is this concurrency, is this task that overlaps at a time, and this is nothing new to the language. In fact, this is something that way predates JavaScript because back in the 60s and the 70s, there is a lot of applications back then that initially was written in assembly or this low-level language that now evolved from the defense department, according to Grady Butch, the co-creator of the UML, where he say, hey, back then, because due the missile crisis and that the Soviets and the U.S. were now posing a threat, not only for both powers, but also through the world, they need to find a way to not only make those systems effective and efficient, but also to maintain that. So now, with the collaborations with the years of the MIT and some of the research area or in the research sectors, that now they're developing is how you can now compute different stuff across different computers, distributed computing. And from there, now those particular problems when it comes to developing and so design and maintains large application, monolithic large application, and now with this new challenge of how do we make this real-time communications app software and also multi-language and handling is the concurrency and time zones. And this is I'm gonna bring this so this is evolution of the software because I think this is quite important to recap so we can understand how do we get here, because once you do that you will embrace complexity. So this is part of the pragmatic engineering. I don't have any affiliation with him. I just find out that this is a very important, from the historical perspective, podcast where now Grady Butch, which is now a chief scientist, chief chief scientist, chief scientist. I don't recall his. He's a chief scientist at IBM, but there was a particularly. He's a fellow, exactly. So he's a chief scientist for software engineer at IBM. Or fellow chief scientists. And he described briefly is, well, how now when he was hired by IBM, the bureaucracy back then realized that this is the kind of people that take care of the next 5 years, not the next quarter. And that's why they now offer this particular position. So in any case, the idea here is to now, by exploring is the history of the evolution of software development, which the history, according to him, the history of the software computer, or again here, so the entire history of software engineering is one about level up raisins of abstraction.
Of software engineering is one of rising levels of abstraction.
Is one of rising level of abstractions.
So what we're seeing here is the rise of another level of abstractions, which gives us all these extraordinarily powerful frameworks from which I can build systems, and which, as I alluded to, the architectural decisions that were front and center for us back then are now embodied in these. So now it becomes a decision, what cloud service do I use? What messaging system do I use? What platform do I use? That's the decision, which has a lot of economic decisions and not just software kinds of decisions associated with it. So I think the role of the architect in effect has changed, because now I'm dealing with systemic problems, not just software problems themselves.
So that was quite interesting. And again, I just want to brought that up is the evolution of software here, right? Briefly.
And also influence a lot of software architecture, the broader field. How would you describe the field evolving over the decades? You were clearly part of some key techniques invented and becoming commonplace. What was this like?
So I alluded to a phase I called the first golden age of software engineering. This is the realm of the time of functional, or not functional, but algorithmic languages such as Fortran and COBOL, APL, Lisp, and the like.
And this is quite interesting because this kind of language like Fortran and COBOL that now we can decompose systems through algorithms. So I'm just paraphrasing some of the things that he mentioned and actually understand each one of those words, because it is quite fascinating when you are genuinely understand how do we get here, so we make sense of this particular topic on JavaScript. Again, I'm going to just show is just the next 5 minutes so we can move on to what we really care in today's video, which is the RxJS observables, and then exploring that. But I think this is quite important to understand how do we get here and have this history background in our back.
Although Lisp was sort of a
in our backpack
kind of language. But the dominant way that we decompose systems was through algorithms. And so you saw the rise of structured analysis and design techniques, which made a whole lot of sense at that time.
So this is structure analysis and algorithm analysis.
This is where you had the Jordans and DeMarcos and Constantines and the like, because the presenting problem for software systems was they were generally not distributed. They were largely monoliths. And how
exactly. So monolithic, not distributed.
Could we build larger and larger systems that were sustainable and economically interesting over time?
Very, very, very important, more than in today's realm, right? Is that how can we build now systems, softwares that are now economically sustainable and maintainable over time. That's why when you go out to work with a particular company, whether it's Merrill or any of the on the financial sectors or any of all of the on the consumer sector, you realize that those particular systems now have a lot of legacy problems, and then it's up to us to define some sort of techniques or discover some patterns. Usually using is now the combination between the mathematics and the human psychology in terms of, hey, we need to find a way to design and maintain all of these solutions, at least for monolithic applications. And then things started to make quite interesting and elaborate when it comes to this, do this distributed computing.
Well, the golden age of that first golden age of software engineering began to change as we started to see the rise of distributed systems. And that rise, again, happened not in the commercial world, but it happened in the defense world. The ARPANET was, funded by the government, funded by DARPA. I was, as I mentioned to you earlier, I got my first email address in 1979 when there weren't that many email addresses around. In fact, one small story there, when we had the ARPANET, I was teaching at the Air Force Academy at the time, we had a little mimeographed document that listed the email address of everybody in the world. I think at that time there were a few thousand people, so we knew who everyone was at the time. It was pretty cool to go back. So the first distributed systems were happening in that domain. Indeed, back to Vandenberg, I worked on a system called the Telemetry Integrated Processing System, which was a close network of some 32 mini computers. Mini computers were beginning to be a thing.
Closed network of 32 mini computers. When mini computers were a thing.
Close network of telemetry integrated processing system. Annenberg, I worked on a system called the Telemetry Integrated Processing System.
Okay, the telegramy. What?
Back to Vandenberg,
Please?
I worked on a system called the Telemetry Integrated Processing System.
Okay, the telegraphy. Oh my God, I'm quite deaf.
Vandenberg, I worked on a system called the Telemetry Integrated Processing System.
Okay, the telegramy integrated processing system. Is that still a thing? Is that still work? Okay. No, but telegramy. Is that currently the name of
Back
this?
to Vandenberg, I worked on a system called the Telemetry Integrated Processing System.
Telemetry integrated processing system, but telemetry integrated processing systems. An integrated processing system for telemetry can include a variety of features such as that enable. My question is that what is telemetry? Telemetry, the etymology of this, etymology of this, come from the Greek word tele, meaning remote. Oh, and metron, measure. Oh my God, for real. This one. Oh, telemetry. Those Greek people actually are they have a lot of time. That's what I can say. Telemetry. Telemetry, but no, it's telemetry. Telemetry. Oh, telemeter, related to telemetry, or telemeter. In 1860, it's reference to a kind of range finder for surveillance and artillery firing. And again, it all started with actually as a companion of war. From French, télémétrie, from télé, far, see tele, and métrie, device or instrument for measuring. The word was used later in the sense of apparatus for recording meteorological observations. Okay, etc. Electrically at a distance, and it was coined by 1953 in reference to a pay-as-you-watch TV system with a coin box attached to the set. From television, related telemetry, art of measuring distance by using of telemeters. So in other words, is device for measuring something far. Okay. The tele before vowels, property tel were forming element from Greek origins, meaning far, far off, operating over a distance. From Greek tele, far off, far at a distance. Related to telos, teleos, genitive of telos, and goal competition results. Oh, so telos mean this? So telo, word forming element used by 19 is a science, and especially biology from Greek telos, the end, limit, goal. Telos, ultimate object or aim. Ultimate object or aim. Telos. In 1904, in biology from Greek telos, the end, limit, goal, fulfillment, completion, from pi, quell, suffix from of root kewel, revolve, move around, sojourn, dowel, perhaps via the notion of turning points of a race course of a field. So telos or telo is the ultimate object or aim. Okay. Okay, something at a distance. Okay. Es el objetivo último. Es el objetivo final. O la mira. The telos. So telemet here is this measuring of something that is far away. Okay. Telemet here or telemetry. And when we say telemetry here, related telemetry, the art of measuring distance by use of telemeter. So telemetry is the art of measuring. Is the art of measuring distance by using a device measuring. So the telemetry is hey, we're gonna use this art of using devices, or is the art of measuring distance using measuring devices. Or using alright. So okay, is the Jesus. So it's the art of measuring distance using a measuring device. So telemetry can be used. Okay. All right. So telemetry. Okay. If you ask, for example, to Claude here. Wait, what? Wow, you're so bombarded? For real? Okay, open up Claude again. Wow, those servers are receiving It's like DDoS, man. It's like DDoS. They're receiving this huge amount of. Damn, this not even work. This not even work. Oh my god. This not even work. So what is telemetry? It is safe to assume that device to measure blood pressure is one of them. Is manometer, blood pressure monitor, device to measure volts, a multimeter. Okay, I'm quite familiar with this. So it is safe to assume that a multimeter, blood pressure device are just couple examples of telemetry devices to the process of remotely measuring and transmitting data from one location to another. So while you mention a multimeter and a blood pressure device, they don't exactly fit the typical definition of telemetry device in a strict sense. Okay, because it's this is a remote shit. What a blood pressure device that sends data remotely can be considered a telemetry device, A standard multimeter typically isn't used unless it is specifically has telemetry capabilities. Telemetry often involves real-time data transmission over a distance. So this is the telemetry, the art of measuring distance using telemetry, or in this case is to transmit data from one location to another. Telemetry for transmit data remotely, which is exactly what we're doing, especially if we are now working with these web applications. Telemetry. Interesting.
System.
Well, this is an integrated processing platform for traffic sector, okay? Integrated management system, Qualcomm, integrated process system modeling performance, but he was working at this telemetry integrated processing system. Okay, interesting. And of course, they are part of the Homeland Security, man.
Which was a close network of some 32 mini computers. Mini computers were beginning to be a thing. And so the problems of how do I deal with taking a larger system and breaking it up into multiple distributed parts was beginning to emerge as a problem. It hadn't reached the commercial sector yet.
Exactly, but it all happens on, okay, it all happened back in the defense, especially with the ARPANET. It's like, hey, how we now have this, which is something that he worked, interesting, Grady Butch worked in this project of telemetry integrated system, or telemetry integrated processing systems that say, hey, how can we now make all of these different computers in a closed network?
Parts was beginning to larger
Exactly.
system and breaking it up into multiple distributed parts.
Exactly. How can we now is
Computers
this?
were beginning to be a thing. And so the problems of how do I deal with taking a larger system and breaking it.
How do I deal with taking a larger system and break it up into multiple distributed parts, distributed computing?
It up into multiple distributed parts was beginning to emerge as a problem. It hadn't reached the commercial sector yet. So we, the industry, began to see that there were limitations to what one could do with algorithmic decomposition. And so there were these pressures all around to try to attend to the next kinds of software. Software that was distributed, software that was real-time, software that was multilingual, software that worked on a variety of computers.
And so software that is multilingual, interesting. So they have now these pressures from programmers back then and computer science back then. They have all these pressures of how they can make these monolithic applications and make it into, in other words, apply algebra. How you can decompose all of this into small pieces of distributed computing. And they have now pressure that now the algorithmic way of decomposing system wasn't enough. This way of decomposing system through algorithm and performance on static and performance on algorithmic analysis like vehicle notation and all that kind of stuff weren't enough. So because now they have to deal with pressures of this new challenge of real-time communications, distributing computings, real-time communications, multi-language, and different computer systems.
That was multilingual, software that worked on a variety of computers.
Software that work on a variety of computers.
And I had to deal with all the normal aspects of distributed systems, which is they're going to fail at various times, and I've got communication issues.
And also dealing with the operations of it.
So it led to a realization that we needed to think about software in very different ways. The other thing that was happening is in research, you saw the rise of languages such as Simula and Smalltalk, which were looking at the world in fundamentally different lenses.
Simula, all right. Simula and Smalltalk programming language. Okay. Simula is a programming language that is considered the first object-oriented language. It was developed in 1960 at the Norwegian Computer Center in Oslo, Norway. Simula was designed for a simulation purpose, and its key features include classes, subclasses, virtual procedures, safe reference. Simula has very used in a variety of applications, including simulated very large-scale integration, process modeling, communication protocols, algorithm typesetting, computer graphics, and education. Smalltalk. Smalltalk is an object-oriented programming language that was designed in 1970 at Cerro Palo Alto Research Center. Smalltalk has influenced many modern programming languages, including Ruby, Dart, Scala, Groovy, Flavor, C++, Objective-C, and Java. Applications. Smalltalk was popular for agile software development methods, rapid application development, prototyping, and software design. Smalltalk was designed by Alan Kay and Adley Goldberg and Dal Ingalls and others. It was created to underpin the new world of computing, exemplified by human-computer symbiosis. Oh my God. In a Smalltalk, object communicates by sending message. Functions are not called, but messages are sent to object. The most popular variant of Smalltalk is Squeak. Interesting. Simula. All right. Smalltalk. So you have now Simula. All right. Let's go to create now. Let me see if actually Claw helped me here. All right. A little bit. Oh, that's great. Generate a basic calculator in Simula and Smalltalk programming languages to see their difference and later generate a basic calculator with latest ECMAScript. With latest ECMAScript. So it's now generating as this through Simula. Oh, you paste all of this at once? No. You need to create is a different file for all of it. No. Okay. Yeah, I wasn't that clear. Create a separate file for each programming language. In Simula, that's right. So this is how do you do that in Simula? It's like, hey, you say begin, class calculator. No, wait a single moment. Begin real result, then you define all of this procedure or methods, and then you define is this, if GS error, okay, this is the handling errors. All right, for this block here, real procedure get results, and begin of it results, where you call now the result. And by the time that you now calculate a class calc by creating a new calculator, here you say, hey, let's go to now add, for example, and print that out. Cal print result. Okay. Cal print result. Because you have a method for that. Cal print, exactly. Procedure, print result, and this is what it's gonna do. Okay, okay. It has a very okay. So now with Smalltalk, you say, hey, I'm going to create now an object from, this is made up by Xerox Palo Alto, and say, hey, objects of class calculator, instance variable name result, class variable names, all directory and category, and all that kind of stuff, instance method for calculator. So this is the object that is going to have is the instance variable names, class variable names, poll directory, category, all right, calculator method for arithmetics, instance method for calculator, and then you define is the different methods, all right, get result, print results. An example of this is this example of usage, and their data, add x with g, result in this, subtract x with this, result in this, divide x with this. If it is true, do this, and then you're going to return that and print result. Transcript show result prints string here. This is the calculator, and then you say you create now a new object, right, where you're going to make that these operations work with that data. So here you say, hey, let me actually call add and pass now 10 with 5, and then print the results. Transcript show, so call this method to print this. Now subtract this with this, and then print that, and all of that. And now when you go with this, now, as you can see, there is now a function constructor that is going to define is the data that you're going to work with, and then the functionality here, which is add, subtract, and all of this, private method for this, so add to history, private method using modern ECMAScript syntax, generator method to iterate through the calculation history. I'm assuming that you are actually defined that. So you get the history and the result, all right? And then you define here the async method example, which is save history, simulating saving to storage. Now we are actually using is asynchronous applications, and static method for this, which is valid number to verify is that, which is something that you might use here. Right, no, we're not using that. All right, add to history. All right, so it's valid number. So this is how you can create your objects, and then well, the print operation using template literals and arrows to say that print results is because he overcomplicates stuff here, but you just only can call his calculator, all right, and add that or subtract or multiply or divide and all that kind of stuff, and using an async in a way to save the history of that. But in any case, even though that this example might be quite obscene or ex, too much. It show now how in those languages at some point they trying to actually is finding a way to combine is the data and it is functionality together. So
So here we are again in the late 70s, and again, I'm what, a 20 something. I was asked by one of my former teachers at the Air Force Academy, say, Grady, would you go help the Department of Defense figure out how to use this new programming language called Ada so we can apply it to modern software engineering techniques? Now, why was the government worried about this? By that time, software was a real problem for the Department of Defense, actually for all of the federal government, because there were several thousand languages in use that exploded because Fortran and COBOL were useful for some things, but not for all things. And so there was a decision made to build one language to rule them all, and that was the Ada programming language. Ada was far ahead of its time. It was a language that was influenced by Simulant, Smalltalk, and others, but it used the ideas of abstract data types from Liskov and Gauguin and others. It used the ideas of information hiding from David Parnas, all ideas that were very new at the time, but frankly are part of the atmosphere in which we breathe right now. And so as an industry, we really didn't understand the methodologies to make that work. Thus was born the Booch method. I was in 79 till about 81. I was going back and forth across the United States, helping the federal government and helping contractors try to apply this new language in new ways. And this was the beginnings of the second golden age of software engineering, in which it was not so much the complexity of the algorithms, but it became a systems engineering problem, systems that were dealing with distributed systems that were very new at the time. And that was the essence of the Booch method. It was the things I learned about helping organizations architect systems with these new kinds of domains and new kinds of languages.
Could you explain what the Booch method is? I understand it has to do with object-oriented programming, but coming from you as the person who invented it, it would be nice to explain what it is and why it was important.
Well, let's go back to Plato. Talking about going way back, I wasn't around then, but I've read about him a little.
me too, man. It wasn't around
there.
then,
He wrote,
but I read about that.
In which there's a debate about
I'm
how
still
one
reading.
should best look at the world. Should I look at it as atoms, or should I look at it as processes? Well, the first golden age of software engineering was more focused upon the processes, the algorithms. But there's a parallel way of looking at the world, and that's looking at it through the atoms, if you will, the classes and objects within them. So yes, I was influenced by abstract data type theory, by Plato, by a lot of other interesting philosophical things that were coming together at the time of looking at the world in fundamentally different ways. So the Booch method was really trying to codify that. How could we decompose systems not based upon algorithms, but how do we decompose it based upon classes and objects? And again, that's where I was influenced by Liskov and Parnas and Dijkstra and Hoare and the like. Names that are probably unfamiliar to students these days, but they were representing the theoretical underpinnings of the first and second generation. The Booch method was basically saying, hey, here's a new way of thinking about the world. And so it said, look not at algorithms, but look at combining data and
Methods, functionality,
processes, algorithms together in one thing.
Exactly. This is the core of this object-oriented programming. Again, this is not a course of object-oriented programming, but now lay down is the foundation of how do we get here in, finally, as what we are going to take a look is at the way of how now all of these systems prior to us, a lot of us prior to even our existence, is they were made to actually solve the specific problems, usually in the defense world, where now they have these projects around telemetries that, hey, how do we now decompose these monolithic applications into simple, and how we can break out that into a distributed computing. So when you are having that kind of challenge, you now have to deal is with real-time communications, the which is something that we're gonna explore that. So real-time communications, multi-language or software that are written in multi-language, software that run in different computings, in real time software that need to run in real time, software that need to deal in real time scenarios, software that need to run on multi-language applications and in different computer architectures. And which is kind of what he mentioned here.
So we knew who everyone was at the net in the air. I was teaching at the Air Force, funded by the government, funded by DARPA. First distributed systems were happening in that domain. Indeed, back to Vandenberg, I worked on a system called the Telemetry Integrated Processing System, which was a close network of some 32 mini computers. Mini computers were beginning to be a thing. And so the problems of how do I deal with taking a larger system and breaking it up into multiple distributed parts.
Exactly. How do I deal with these bigger systems and breaking down into several parts?
Was beginning to emerge as a problem. Hadn't reached the commercial sector yet. So the industry began to see that there were limitations to what one could do with algorithms.
Exactly. So there are limitations to what we can do with algorithms.
Rhythmic decomposition. And so
or algorithmic decomposition
all around to try to attend to the next kinds of software that was distributed, software that
software that is distributed, software that is real time, exactly software that is distributed, software that is multi-language, software that runs in a variety of computing, software
that was real-time, software that was multilingual, software that worked on a variety of computers. And I had to deal with all the normal aspects of distributed systems, which is they're going to fail at various times, and I've got communication issues and the like. So it led to a realization that we needed to think about software in very different ways. The other thing that was happening is in research.
So this is a good overview of this, at least for myself, to actually make sense of how do we get here, all right? So we can move on to what we really care in this area, especially with the JavaScript applications, to understand now how can we deal with these distributed applications, this real-time communication that can happen over time. Luckily for us, we don't need to deal, at least in JavaScript, with the software that are multi-language. Only, for example, or at least in the client and the server, if you use now JavaScript, Node.js, that'll be a good advantage. If you're not, well, you have to actually deal with software that are multi-language. So you have now the clients using HTML, CSS, and JavaScript, and also you have now the server, which can be used as Ruby, PHP, Python, you name it, and software that run on different computer systems, right? Hey, is the RM architecture, or is Jesus is the RM architecture, or is Intel, at least right now? Oh my God. Oh my God. And also with the nature of distributed system, that it can fail at some point. So, because in JavaScript, luckily for us that Kyle seems to actually make this quick recap of this, right? About what are the tools that we have in the language to deal with this asynchronous nature, with this concurrency nature, right? With the ability of our systems to now work in a distributed environment. Now, not in closed networks, but also in open networks. So, for example, like the internet, right? This is massive. This is huge. So, so what are the tools that we have in the language, or at least that provide us by the platform, to deal with this kind of systems or this concurrency or applications, right? This is in. It makes a lot of sense of why we're doing the kind of stuff that we do, and why we're getting hired to do that. You know what I mean? So, not only to be capable of design and maintain software applications, particularly React or JavaScript applications, right? But also is how do you now is handle is the concurrency in your applications, this distributed nature. At least right now, using only JavaScript, all right, and understand that the language in it itself, it is a single thread. It means that it works similar that our brain, which is not in parallel, is in concurrence way, at least cognitively speaking. So, from the biology perspective, of course, there must be a lot of things to put ourselves together. Otherwise, we will like jelly, or will be like a constellation of jelly atoms in this space, or who knows. So, with this concurrency, and understand now what are the tools that we can use here as JavaScript developers, this is the next level of competency, absolutely, to not only help business and ourselves, to help them to provide is software applications or to improve their business operations, to make them economically and sustainably interesting. So, all right. So, because of that, JavaScript is a single thread language that now it means that it's going to run one line at a time. And now this is just in time compilation, which is now to bring the gap between or close the gap between the applications on the net, between interpret and compile language, right? So since our line of code runs one after the another, and when we need to deal with concurrency or this asynchronicity, because everything forward here is based on this foundation, using now the timers or the callbacks, okay? So we also have now this way of deferring tasks, or to pass that, or to delegate tasks, using is the event loop notions, where you can now use, for example, service worker to actually is essentially creating is a new process that is going to now run your application, and you can communicate through other processes via service workers. And again, this is now some of these particularly problems when writing applications here in JavaScript, and how do we handle with writing the software and dealing with the concurrency in your applications. So, because when you're writing this kind of applications with JavaScript, and especially since JavaScript is now run not on the not on the OS, is run on the browser, and the browser is a process in itself, and the process is now this separate program that has its own resource, where now this particular process, they can communicate each other, and the way to do that is by several different mechanisms. So you can think of this different process as different computers that they cannot communicate each other directly unless they have certain methods to do that. So this is known as the IPC. So they communicate through the inter-process communication. So it can be is via pipe, which is unidirectional. It can be bidirectional via sockets, or like a dashboard or a whiteboard via memory, sharing memory, or via message brokers. It's like, hey, someone actually is coordinating is all of this communication, all right? Or through emergency signals. This particularly concept, especially for software architectures that are now this is the kind of problem that we are dealing, especially if you now decompose all of those systems into or decompose all these massive systems into multiple ones. Because of that, right? For our purposes, our case is as JavaScript developers that we need to handle this concurrency. This is the tool that we can go with and understand how do we get here with observables, especially with this event reactive, is something that is going to make sense as we develop our applications. So we first has on the language, which is provided by the platform, not native to the language, is timers, aka callbacks, all right? And how now can we deal with this concurrency and also the trade-off, which is the inversion control problem, and they're not reasoning about. That's why now, and also is the time coordination. Again, we also look at example of doing that. I'm just going to dive deep into the observable so we can actually get our hands dirty by writing this kind of applications. But it's like we have callbacks, they have its trade-offs. Now thongs, which is something that way predate JavaScript, it say, hey, this is a thing that help us to eliminate time as a concerning factor in our applications. So anytime we need to fire up several Ajax requests or run this callbacks or this continuation of a program at some point in the futures, well, we don't need to worry about that because we're gonna get that value by passing as a callback. So these thongs help us here to eliminate time as a concerning factor, which is a huge deal, all right? And he's using now concepts like closures to do that. And now promise kicks in and say, hey, this is now how we're gonna handle our concurrency in our application natively, which come from a programming language called E, made by one of the TC39 commit members, named Mark Miller, among other collaborators, where they have something called future. Now we have is this promise, where is the idea around that we need to eliminate time as a concerning factor wrapping around a value. That's what promise is. So promise is when you go out to a restaurant, your favorite restaurants, and you, let's say, you order a pizza. So usually what you get instead, once you pay for that, is a receipt, is an IOU, is a promise of that. So when you wait for when you wait for that, or they say, hey, those numbers in that order are announced, or well, when those orders or when those magic numbers in your receipts is announced, now you go back to the counter, receipt at hand, and then you get now your pizza. So the idea of this silly example is to recognize that it's like, this is a good and powerful stuff. You don't have to worry about the time. You just only, by the time that is done, you subscribe to the dot then, which is part of the methods. Or if something went wrong, to the dot catch. So this promise is now a callback manager or an event listener that you might take a look at this, all right? And there are some other abstractions that are helpful to cover some of those use cases. So promise now solves the problem of inversion control, because now we have back that trust, which is something that when you pass a callback, you don't know, or you hope that these functions don't run too many times, or too late, too few times, or too early, don't swallow errors, preserve the data context. So now promise guarantee you that, right? It only fires once, but also it works as a control mechanism in data flow. However, because promise here has other issues, which is they are not local, or they are not sequential, and we have also these local issues when we're passing all of this callback that might have in different, so our code might have in different codes, right? Now generators, which is a pattern, or in this case, is a way of describing is in state machines. So now we have that syntactically here in our language by saying, hey, we are now capable with generator is, as the name suggests, not only generate values, but also is to give us the ability to pause, pass control, and resume the function execution, because functions traditionally run to completion, but now here we have the ability to run until it finally yield keyword. So it doesn't mean that it won't continuously call different functions, or in other words, it doesn't mean that these functions that run to completion will not, at the middle of the statement or the function body, call different functions. This is known as cooperative concurrency, not preemptive concurrency. It means that you can, in JavaScript, the function of a body, to preemptively add some sort of instructions to run that code. So with this notion of the state machines, which is generator, is this syntactic form of describing here this pattern, which is a series of flow from one state to another, and descriptively lists out the transactions out. And descriptively lists the transactions out. The point of this, which is great, is not only for generating values, but also is for defining its flows of executions, control flow of execution, especially those that are relevant for async operations. And we look at a couple examples of how can we do that using is now the promise, because at the end of the day, a generator create now an iterator, which is the mechanism that allows to control this function execution. So anytime you create now a generator, it gives you an iterator that allows you to now get in, pause, pass controls and later on resume. So resume, pass control, pause, and resume, and then you got this workflow, which is great for handling now these things that need to be wait. So this is generators, right? Or coroutines, particularly generators. And then we look at the event reactive or the observables here, because what happened when we need to deal is with series of eventual values, because promise, that's what it is. It's an eventual value, but a single one. It works only one. So what happened when now we need to deal with this series of eventual values, right? Remember that we're working in this distributed environment, right? And somehow you might have a server that is good at, you might have a server for database, or a, for the other is for handling is payment, and the other is the analytics. And then how now you coordinate among all of this data, right? And especially once you receive a request from the users, and then how you now coordinate all of this response. Say, hey, a user want to know is, or we want to know how long a user actually is being in a web page. So, well, we have to take a look at the database server and then to the analytics and some of that kind of stuff. If you don't have that data stored in the analytics, you just only have that in a you might have that information stored on the analytics server, not on the database or the user's database, you know. But things started to make sense here. And we need a particular way to describe those series of eventual values, that once we receive that, we want to apply some sort of steps and then distribute that in our system. So this is a good example. A good example of this is, for example, spreadsheet. Everybody loves a spreadsheet. I really do. I am obsessed with that. But because now with spreadsheets, you can define is the value or calculated value. So let's say you have now in C1 number 10, and then in C2 whatever is on the C1 value times 5, and then when you hit enter, it actually calculate that, or it calculate that. Now it's 50, and then you say, hey, in this C3, you want is to take whatever is on the C2 plus 10, right? When you hit that, then you get that value, which is 60. So if you change some of the values along the way, or if you apply some sort of transformation along the way, you are going to reflect those changes on that, right? So you are applying that transformations or that change to all of those along the change. So because we don't have that natively in our language, especially with observables, we have now is to go with a library that was developed by some of the smart folks at Microsoft, that of course they have that particular problem, and they say, hey, you know what, we need to find a way to model this and to help us for real. So even though that they have this particular approach with how do you deal with this series of eventual values, the observable is still now in a draft, at least at December 2024. And well, we dive deep into the RxJS with the hand of Steve Kinney, the instructor of Frontend Master, to understand now what observable is, how can we use the RxJS for that, in describing some of the most common UI patterns that help us with that, because this is most of the time how we as UI developers need to handle stuff, usually from user inputs or from server events, and understand how to set up observable, how to test that, and how to work with then or how can we manipulate data in times, and eventually orchestrating across multiple API requests. So RxJS is a Lodash for events, right? As I mentioned before, pretty straightforward. And well, we're gonna make sure of or understand is these basic observables here. So we got of, we got from. The subtle difference between them is that of is for single values or objects, from is for array-like iterators, or promises, or even observable like, right? And how now we consume those eventual values when we subscribe to that. We also explore that how can we do that down deep. We create our own custom logic observables, which is pretty much like promise, but here you say, hey, I don't want to create these promises. Sometimes you might want to create those promises, not resolve or reject. But here with observables, pretty much you're not gonna build that. It is useful to see how can we do that. That's right. And this is now, as a integrating and now understanding is the subscriber contract that's going to now generate or yield this series of values. At least in our case is synchronous, all right? We're gonna see how can we do that is asynchronous, all right? By setting a set timeout as well, all right? And how now anytime once you complete or throw an error, it is done. So you stop is streaming data. All right, so far so good, right? Now, what we really care is on the fromEvents, right? There's now events here. There you got it. Events.
In a lot of cases, right? Like once that page loads, trying to think of all the things that could happen that effectively cause change on the page. API requests, any kind of event, mouse move, click, whatever you've registered click event listeners for, are some of the more common ones that will kind of come through. If you are getting fancy with like client-side routing, that could be another one, right? You have a stream of route changes, right? But generally speaking, events are a pretty common one. If you think about it under the hood, prior to the fetch API, right? XML HTTP request had events. Your route change is probably listening to events. Events are basically the bread and butter of our actual UIs.
Bread and butter. Exactly. So events are basically the bread and butter of UI developers, or of actual UI, of UIs.
And so just like we have of and from, we have one called fromEvent. And it creates an observable from an event. And it looks somewhat similar to an event listener, right? So on the top I have basically an event listener where we add event listener click and we say console log it. With our observable, we separate those two things. We separate the creation of the subscription to the event and then what we want to do with it, right? And so again, this gives us the ability to basically have one event listener that we can use multiple places. Different things can subscribe to those events. Like I said before, one of the interesting parts about observables is they each get their own subscription, 0, 1, 2, 3, 4. In this case, like those will be the events as they come through, right? And one of the things we can kind of take a look at later is there are ways to kind of replay events that have happened. If you need to like catch up or stuff along those lines, there are operators that will allow you to do that. But generally speaking, this allows you to separate what to do with the subscription from the subscription itself. So it does take, if you do need to modify that event at all though, and you want to say, okay, like listen, I always want the event target value in this case, you can pass it a function that will go and do something to that event upon subscribing to it. However, later we'll see that you can always want the event target value in the subscription itself. So it does take, if you do need to modify that event at all though, and you want to say, okay, like listen, I always want the event target value in this case itself. So it does take, if you do need to modify that event at all though, and you want to say, okay, like listen, I always want the event target value in this case, you can.
So you're creating a subscriber.
So it does take, if you do need to modify that event at all though, and you want to say, okay, like listen, I always want the event target value in this case, you can pass it a function that will go and do something to that event upon subscribing to it. However, later we'll see that you can take observables, you can map them. A lot of things you can do with arrays, you can also do with observables, just like on the in the fourth dimension, effectively, and have some of those in place. There are a few more that we're not going to get into today because they don't necessarily apply to us in quote-unquote front-end engineering, but they are kind of useful, and I just want to put into your brain so that you're aware that they exist, so you don't try to like write them.
Okay.
There's one.
Okay. So events. From events, events are basically the bread and butter of UI, right? So it makes a lot of sense. So you can also say, hey, I want to now is
modify that event at all though, and you want to say, okay, like listen, I always want the event target value in this case, you can pass it a function that will go and do something to that event upon subscribing to it.
Okay. So you can pass a function to only subscribe to a value to that?
However, later we'll see that you can take observables, you can map them. A lot of
So you can pass functions to only subscribe to a relevant source of truth, or to a relevant source of data. In the above example, okay. In the above example, the event.target.value, in this case is the values, makes a ton of sense.
things you can do with arrays, you can also do with observables, just like on the in the fourth dimension, effectively, and have some of those in place. There are a few more that we're not going to get into today because they don't necessarily apply to us in quote-unquote front-end engineering, but they are.
So we are also going to look other events that are not part of the UI engineering, but useful overall, especially for backend developers.
Kind of useful, and I just want to put into your brain so that you're aware that they exist, so you don't try to write them yourself. There's one called
but useful overall, especially for backend developers, so we are aware that they exist.
bind callback, and this is super useful if you're using Node.js, for instance, right? Which basically deals with, you know how Node takes the error as the first argument and then the results as the second argument? It is basically a helper function that will take the kind of Node style of callbacks and turn it into an observable for you.
Exactly. It's
Second argument.
the Node callbacks and taking them into an observable here. So I can subscribe to that. God damn it. So I can subscribe to that node.js binding and subscribe to this. Holy moly. This is pretty much like inspection.
It's basically a helper function that will take the kind of node style of callbacks and turn it into an observer.
Bind callback. So bind callback. Holy bro. Stop. No, don't translate this, man. Do not translate it. Bind node callback. Or bind callback. Holy moly, bro. Bind node callback. And this one. Convert a Node.js style callback API to a function that returns an observable. Oh, crap. Exactly. So if you do something like this and then you transform that by Node.js callback, right? Use or on function something like this. Do you have at least an example of this? Where in this case is say bind callback is not defined, of course, because you need to install that. So please install. Oh, it's because you need to call this. You can also do something like this and say, hey, node fs, and then you say, hey, import from RxJS the bind node callback, right? Not sure which node version are you using. So you transform that into an observable, read file as observable. Oh my God, I need no CLI code sandbox. Jesus, it's like you're too slow, bro. You're too slow for me. Too slow for me. No. Create a single node.js. This is up or RxJS. The TLDR of that is reactive JavaScript. Makes a ton of sense. Okay, let me actually install RxJS on the dependencies. That's right. Install this. That's right. All right, now run the it say, hey, import Jesus, French toast. Here we go. Stop. No, no. Model. This is, it's type model. No. Model. I don't need to actually do this. No, that's not required. Stop being annoying and run this. And it say, hey, okay, type model on this. Okay, so import that's right. And now it say, hey, error, end of file, no such file directory, or oh, because we don't have that file. So if we define now this particular file here, you say, hey, road map, road names, console log and console error. And here we're dealing is this. Exactly, San Martin, where and then you get all of this. So, but now you transform that into an observable. That's quite interesting.
For you. There's another one that's kind of in its own separate module in RxJS called fromFetch. You can take a lucky guess what it does. Is it creates an observable using the fetch API, right? You're like, isn't that a promise? Yes. but it's a promise that has like a few interesting things like the ability to like abort the request, so on and so forth. So it depends. Like if you're using like a library like Axios or what have you, you might choose to just use fromPromise. If you're using the Fetch API directly, then you might choose to use this as well. Yes, a lot of times, a lot of our API fetching libraries tend to be promises, and you can use from and create the promise, but this is also another option if you're using the Fetch API directly. We will use this one later today. We will not use bind callback because there's just not a use case for it. We have a little application called fromEvent. At this point, you do want to clone down the repo and do npm start, because if you just go to the published version and you change code, nothing will happen because that's not your code. So you can spin up the local server. It is at localhost 1, 2, 3, and 4. In this case, what we want to do is, this is real simple. There's a helper method called addMessageDom. We just want to get a little bit of experience using a fromEvent helper in the same way we did with of and from. And then we're kind of getting all these small pieces, collecting them, understanding them, and we will build to somewhat bigger and better things as time goes on.
Okay, let's go to collect all of this
So
and string for
super straightforward. Our job is
fromEvent. Okay, let's get into actually is through the code. Finally. All right. It's on the API. It's on the utility. It's on the share. Okay.
is to find the button, create an observable from the button, subscribe to. We have a little application called fromEvent. At this point, you do want to clone down the repo.
Okay, because fromEvent. From event exercise. Okay. Okay. There you got it. fromEvents. That's interesting. Why I don't have that? Oh, it's under the application. There you go. Okay, from the event, there you got is this a single HTML. You say, hey, extend from source bay, block head, block this. This is notification center. Main sections and block and extend. Okay, cool. So we got is this. So we got in the bottom here. Let me follow me along with this. So all right, so this is our index here. We got a bottom, create notification message, and what we're gonna do is to actually, well, get those elements, so query those both elements, create notification and notification message, create notification element, and oh, this is creating the notification, okay, and then append this thing, something happened, and then return the message. And then the other is the add message to the DOM. This is to create a notification, and this is to add the message to the DOM. which is append the child. Exactly. So your mission is use fromEvents to create an observable that stream click events, subscribe to that observables, and add message to them to add a useless message to the DOM whenever the string emits a value. So we can do a create a function, say hey, or in this case we can define is something like this. I'm going to create here is observables. First we can create the observable here, which is the observable with the $sign. fromEvent is going to take several arguments. First is the target elements, the query elements that we get, which in our case is the button. Hey, this is the source, the target. The event name that you want to subscribe to, or the event name exactly that you want to subscribe to, and that is click, right? Followed by the options. If you can specify, or if you want to specify now what you want to do here, right? Option, something like this. If you want to specify, it's like, hey, this is the data that I want to get, that I want to receive that, all right? And because we can say is something like this, and it's to say, hey, from that event, all right, from that event, I only want is the click event. And the funny thing is that what is going to return? You know, that's a good example. Okay, let's go. What is going to return? What is going to return? Because if I can subscribe to the observable, if I create a new subscriptions to the observable, to these eventual values, and here I'm going to handle is a happy path, which is, hey, I'm gonna get is the value, all right, and then I want to now call is this function called add message to the DOM that's going to append that whatever it is. It doesn't receive anything, right? It doesn't receive anything. I just want to know is what is the value that we are actually sending anytime a click is being passed through, right? So the question is, how do we run this code? How do we run this code? How do we run this code?
Pro and do npm start will happen. So yeah, super straightforward. Our job is to add a HTML element. You better have stored that function into a variable, so then you can remove the reference to that function from the event listener, so on and so forth, right? fromEvent seeks to protect you from all of that fun stuff with event listeners and kind of encapsulate that. So now you can create your stream. You can subscribe and unsubscribe like as its own separate thing. You'll get back an object that will allow you to unsubscribe, so on and so forth. So here we'll say, I'll call it button clicks. That seems like a really good name for this observable. And so what we'll say is we'll subscribe to it in this case. So button clicks, and we'll subscribe. And we'll say when that happens, we want to add the message to the DOM. Cool. All right. And so let's just make sure that that works. So we'll go here to generate observables from events, except I will use the one that is local, because if I use the production one, it's going to happen. And we can see we get what we think we're going to get here, which is when the click happens, it will go ahead and run the listener, right? We could theoretically
So if we go to the terminal and say npm run star or npm star, okay, where did you launch that? In the port 333. Okay. Necio. Leave the page. Oh, and there you got it. No, but this is the API Pokemon. What? No, applications from event index. Okay. Oh, it's redirected me by default to that. So applications, application from event from event / index.html. So index.html, and it say, hey, can I get the application from that? That's interesting. Unless I say npm run UI. Oh, I get it. 1, 2, 3, 4. There you go. So when we click here, it's actually now something happened. Okay. So it's actually showing us that. My question is that, what is the value that you are sending? You are now sending is a target by default. Okay. You are sending is a target with the event in itself. Okay. All right.
take this and do other things with it as well. So if we wanted to go in here and we wanted to say, okay, not only that, but I would also log it to the console, or we could even alert. Yeah, let's alert. Why not? All right, so we have one stream of events happening, and then we can subscribe to multiple things in this case. So now we'll go ahead, we'll refresh. You can see that I get the alert, and also I get the notification on the page as well. And so there's a bunch of other things that we'll do as time goes on. Like clearly the ability to click buttons and interact with the UI is a thing that is kind of core to what we all do building user interfaces. So we will kind of play with this more in a little bit, but right now we're kind of just building out that tool set of fundamentals in this case.
So in this case we can say it's like, hey, using is the point-free annotation to say, hey, if you have the same function here, you're gonna do that. And then you create now this kind of stuff. You can also say is, hey, this observable, which is button clicks, okay, and then you now hold this observable here, and also here you can subscribe to the same source of events. You can exactly. So here you're subscribing is to the same event source, and you say, hey, I want you to now is run is an alert. Say, hey, someone click. So you save that, right? And when you click here, go back to the browser. This is it, right? You click here. So now it goes first for the alert and then add that to the DOM. That's interesting. The same for this. And that's it. So you can see you are now subscribing is to the same event source for that. So that'll be all for this video. Take care. Bye-bye.